All right, how do we graph a sine function? Well, let's think about in xy coordinates. Sine is which of those coordinates? It's the y. All right, so we're going to look at the y coordinates on this unit circle. As we go around the unit circle, what are the y coordinates? So here at 0 pi or 2 pi, we have the coordinate 0, no, that's wrong, 1, 0. Right? So here we have the point 0, 1, negative 1, 0, 0, negative 1. Now for the unit circle, one full rotation around the unit circle, right? So one full rotation was 2 pi all the way around. Whenever we graph sine, that'll be our period of oscillation. So one period of oscillation will be 2 pi. All right, now we're going to make a table of values for our graph. The x, we're going to treat it as the distance that we're going around the unit circle. So I'm going to use these main points, 0 pi. Our next step was pi over 2. Then we went to pi, 3 pi over 2, and 2 pi. And the y's, I'm going to look at the y values at those distances around the unit circle. So whenever I got to 0 pi, my y value was 0. At pi over 2, my y value is 1. At pi, it's back to 0. 3 pi over 2 is negative 1. And at 2 pi, we're back to 0 again. Okay, so we're going to set up our x-axis. These are all positive values. So we have 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And the y-axis, it only went up to a positive 1 and came down to negative 1. Now I'm going to plot all those points. So at 0 pi, we were at 0. At pi over 2, we were at 1. At pi, we were back to 0. 3 pi over 2 was at negative 1. And 2 pi, back to 0. Whenever I connect these with this smooth curve, I get a sine wave. Now this is just one period of the oscillation. This wave actually keeps going and repeating itself over and over and over. Okay, so let's talk about the parent function and its properties. We notice that it starts here at 0, 0. That's going to be super important whenever we get to cosine. We need 4 increments, or 5 points, to complete a period. So here, this function just keeps going and going. But one period was from here to 2 pi. Right? After that, it's going to start repeating itself. And our increments were there, there, there. So from my beginning to my end here, I have 1, 2, 3, 4 steps from the beginning. 1, 2, 3, 4. And it's bounded by negative 1 and 1. Right? Like this is as tall as it goes. This is as low as it goes. And that's called the amplitude. Also, I just changed this 1 right here. This said negative 1 a second ago. Sorry. Okay, so the amplitude is the absolute value, because it's a distance, from the x-axis to the max or mins. So, like from here to to the x-axis, this is the amplitude. Right? And for this case, it was 1. The same thing down here, even though we're going negative, this amplitude is still 1 because that's how far it is from the wave back to the x-axis. Okay, now, all of these sine functions, they're not always going to be bound by 1 and -1 or just have a period of 2 pi. Whenever you have y equals a sine bx, that a is going to tell us the amplitude, and those will be our bounds. So this a, first thing you're going to do is only look at the absolute value of a. Okay, that's the amplitude. Now, if it is a positive a, you'll start your graph by going up first. If it's a negative a, you'll move down first. All I mean by up first and down first is like from 0, 0, you go up like that. If it was negative, you would start by going down. Okay, and then the other thing is that b. We use the b to find the period. So 2 pi divided by that b will give you the period. And then for those increments, right, I need 4 increments. All you have to do is take the period and divide it by 4. That word is not really going to fit right there. Okay, increment. And we'll just call that I. Alright, so let's do a couple of examples where we're going to find the amplitude and the period. So first, y equals 7 sine 2x. The amplitude is just this 7, whatever's out there in the front. So amplitude is 7. And then the period I take 2 pi and divide it by b. And what's that b?
2.
2. So what's 2 pi over 2?
2 pi.
It's pi. Okay, in this next case, what's the amplitude of negative 3 sine pi over 4x? Remember that the amplitude is always an absolute value. So the amplitude here is 3. And then the period, we'll take 2 pi and divide it by pi over 4. So this is the same thing as 2 pi times 4 over pi. So the pi's cancel, and 2 times 4 is 8. So the period of this is 8. Alright, these are the rules for graphing the sine functions. Just take a second and pause and write these down. Okay, so let's look at the example. Y equals 2 sine 4x. So the first step is to find the amplitude and plot it on the y-axis. So what's the amplitude of this example here? 2. Okay, so got my graph. The amplitude is 2, so I'm just going to put 2 and a negative 2. Alright, next step, find the period and plot the fourth increment on the x-axis. So to find the period, it's always 2 pi divided by b, and the b is 4. So 2 pi over 4 reduces to pi over 2. So 1, 2, 3. The fourth increment is pi over 2. Okay, the next step is to find the increment and plot the x values. So to find the increment, I'm just going to take my period, pi over 2, and you always just divide that by 4. But if you have a fraction, remember that dividing by 4 is the same thing as multiplying by a fourth. So that would be pi over 8. Okay, so whenever we're plotting these, so we're going to start at 0, and then I'm going to go 1 pi over 8, right? And then we're just going to multiply here. 2 pi over 8 is pi over 4. 3 pi over 8 doesn't reduce. And then 4 pi over 8 should give me pi over 2, which it does, right? Okay, now determine the direction of the oscillation. I do that by seeing it's a positive 2, so which way is it going to go first? Up.
I feel like you're literally getting these numbers out of your butt.
So I'm going to plot 0, 0. It goes up first, so up here at 2. And then just complete the wave. Connect through. And yours probably looks nicer. Alright, so let's just do it one more time. Y equals -5 sine of pi x over 3. Alright, so what's the amplitude of this function?
-5.
It's positive 5, because the amplitude is always an absolute value. Okay, so I'm going to start by plotting that. 5, -5. Okay, the period, I take 2 pi and divide it by pi over 3. So that's just 2 pi times 3 over pi. Pi's cancel, and the period is 6. So my last increment, we're going to end at 6. Okay, and then just to figure out these numbers inside, I take the 6 and divide it by 4. So I'm going to be counting by 3 over 2. Okay, so if you think about the increments as steps, you think, okay, my first step, I take 1 step of 3 over 2. And then for your second step, I'm just going to do this off to the side. My second step would be 2 steps of 3 over 2. So how far have you gone if you've 2 times 3 over 2? It's just 3. Right? The 2's cancel, or that's 6 over 2, which is 3. And then if you take 3 steps of 3 over 2, how far have you gone? 9 over 2. And then finally, 4 steps of 3 over 2. Well, that's the same thing as 12 over 2, which is 6. Right, so that's where these numbers are coming from. Now, what's the direction of the oscillation? Down, and that came from that -5. So start here at 0, and then I'm going to go down to -5 for my first step, and complete the wave. Now, I want you to be careful to not start your wave like that, right? These should look more like U's. It just kind of curves down into it. They're like little bowls. Okay, and this actually keeps going, right? But we're just going to be focusing on only graphing one period of this wave. Okay, and that's how we graph our basic sine functions.